And now I am going to do the question by second way. As I told you in the very beginning that I will do this question in three ways. Now I am going to do this question by second way. The second way will be only mathematically different. The theory which will be used in this way will be same as the theory I used in previous way. And in third way also, that way will also be only mathematically different, but the theory will be same as I discussed in the first way. Just to recall, again I will tell you that line will work as edge of the tetrahedron if that line is of the type AB, AD, CB or CD or AC. BD is the line which is the line of intersection of P1 and P2 that is already given to us. The line will be of the type AB or AD if that line completely lies in the plane P1, or second possibility is that line completely lies in the plane P2, that is of this type or this type. Next possibility is the line is of the type AC, that is the line is cutting the plane P1 and P2 at two distinct points. To use this theory in the second way, first of all, I will find the combined equation of the plane P1 and P2. The combined equation of the plane P1 and P2 will be 10x plus 15y plus 12z minus 60 into minus 2x minus equal to 0. Because for any point on the plane P1, this will be 0. Hence, this is 0. And whatever is this whole will be 0 for any point on the plane P1. That is, I can say every point of plane P1 will satisfy this equation. Similarly, for any point on the plane P2, this will be 0. That is, this part will be 0 for every point on the plane P2. And for that point, whatever is this, because this part is 0, 0 into anything is 0, therefore every point of the plane P2 will satisfy this equation. And just for knowledge, I am telling you, every point of the line BD, because that lies on the plane P1 and P2 both, therefore for every point on the line BD, this will also be 0, this will also be 0, 0 into 0 is 0. Therefore, every point of the line BD will also satisfy this equation. That is, this equation represents set of all those points which lie on the plane P1 or on the plane P2. And now let us deal with the choice A. That is, I have to check whether this line can be an edge of this tetrahedron or not. For this, let us suppose this equal to alpha. That is right, x minus 1 by 0 equal to y minus 1 by 0 is equal to z minus 1 by 5. Let it be equal to alpha. That is x equal to 1, y equal to 1 and z equal to 5 alpha plus 1. Note that 1, 1, 5 alpha plus 1 lies on this line for every value of alpha. And now I will check where this line cuts the combined equation of planes. For this, I'll put this point in this equation. Listen the statement I'm going to tell you now. See, if this part is satisfied for every value of alpha and this part is satisfied only for one value of alpha, it will mean that this line is of the type AB or AD, and the value of alpha I get from this part. By putting the value of alpha here, I'll get the coordinate of the point B or D. Therefore, this line will be edge of the type AB or AD. If for this point, this is 0 for exactly one value of alpha, and this is 0 for all values of alpha, it will mean that this line is of the type BC or CD, and one value of alpha I get from here. By putting that value of alpha here, I'll get the corner of the point B or D. If for this point, this also becomes identically 0, this also becomes identically 0, this will mean that this point lies on this plane also and this plane also. In that case, this will become the equation of the line BD. If by putting this point in this equation, this part also gives one value of alpha, this part also gives one value of alpha, and those two values of alpha are different, it will mean that this line is of the type AC, because in that case the line is cutting these two planes P1 and P2 at two different points. If by putting this point in this equation, both parts give same value of alpha, it will mean that this line cuts these two planes at same point. It will mean that this line is cutting this line BD. That is, this line will be passing through edge BD. If by putting this point in this equation, this becomes 0 for every value of alpha, and this is non-zero for every value of alpha, this will mean that the line lies in the plane P1 but never cuts the plane P2. That is, the line will be parallel to the point line BD. Hence, this line will never cut the plane P2. Hence, it will not be edge of the tetrahedron. Similarly, by putting this point, if this is non-zero for every value of alpha and this is 0 for every value of alpha, this will mean that this line lies in the plane P2 and never cuts the plane P1. Hence, it will mean that the line is lying in the plane P2 and parallel to the line BD. Hence, it will not be edge of the tetrahedron. That is, I can say the line will not be edge of the tetrahedron in three possibilities. Either this line is of the type giving same value of alpha from here and here, that is, this line will cut the line BD, hence it will not be edge of the tetrahedron. Or second case, the line lies in the plane P2 and parallel to the line BD, or the line lies in the plane P1 and parallel to the line BD. In these three possibilities, the line will not be edge of tetrahedron, and all the cases I have discussed just now. Now let us proceed further using this thing for all the given lines. Let us put this point in this equation. Now putting this point in this equation, I get 10 plus 15 plus 12 into 5 alpha plus 1 minus 60 into minus 2 plus 5 plus 4 into 5 alpha plus 1 minus 20 equal 0. That is, I get 37 plus 60 alpha minus 60 into 3 plus 20 alpha plus 4 minus 20 equal 0. This will mean that alpha is equal to 23 by 60 or alpha is equal to 13 by 20. And because I have got two different values of alpha, it means this line cuts the plane P1 and P2 at two distinct points. That is, the line is of the type AC. Hence, it can become edge of the tetrahedron. In this way, we will be dealing all other lines also, but for clarity purpose, I will solve for other cases also. Second possibility is line is given as x minus 6 upon minus 5 equal to y upon 2 equal to z upon 3. Again, suppose let it be equal to alpha. I'll get x equal to minus 5 alpha plus 6, y equal to 2 alpha and z equal to 3 alpha. And now I'll put this point in this equation. Note that this alpha is different from this alpha. This case I have already taken. Now putting this value of x, y, z in this equation, I get 10 into 6 minus 5 alpha plus 15 into 2 alpha plus 12 into 3 alpha minus 60 into minus 2 into 6 minus 5 alpha plus 5 into 2 alpha plus 4 into 3 alpha minus 20 equal to 0. That is, I get 60 minus 50 alpha plus 30 alpha plus 36 alpha minus 60 into minus 12 plus 10 alpha plus 10 alpha plus 12 alpha minus 20 equal to 0. That is, I get 16 alpha into 32 alpha minus 32 equal to 0. That is, alpha is equal to 0 or alpha equal to 1. Hence, again, I have got two different values of alpha. Hence, this line can be edge of the tetrahedron and the line will be of the type AC when it will be cutting both the planes at two different points. And now let us take the third case. The equation of line is given as x upon minus 2 equal to y minus 4 by 5 is equal to z by 4. Again, let it be equal to alpha. Therefore, any point on this line will have coordinates minus 2 alpha, 5 alpha plus 4 and 4 alpha. And as I told you in theory, now I will put this point in this combined equation of two planes. Note that the point is minus 2 alpha, 5 alpha plus 4 and 4 alpha. And putting this point in this, I get 10 into minus 2 alpha plus 15 into 5 alpha plus 4 plus 12 into 4 alpha minus 60 into minus 2 into minus 2 alpha plus 5 into 5 alpha plus 4 plus 4 into 4 alpha minus 20 equal 0. That is, I get minus 20 alpha plus 75 alpha plus 48 alpha plus 60 minus 60 into 4 alpha plus 25 alpha plus 16 alpha plus 20 minus 20 equal 0. That is 93 alpha into 45 alpha equal to 0. That is, both have given the same value alpha equal to 0 and 0. It means this line is cutting both the planes P1 and P2 at same point, which will mean that this line is cutting the edge BD. Hence, this line cannot be edge of tetrahedron. And lastly, to check this choice, again suppose x upon 1 equal to y minus 4 upon minus 2 is equal to z upon 3. Let it be equal to alpha. Therefore, every point on this line will be of the form alpha, comma 4 minus 2 alpha, comma 3 alpha. And as in the previous cases also, I will put this point in this combined equation, and now putting this point in this equation, I get 10 into alpha plus 15 into 4 minus 2 alpha plus 12 into 3 alpha minus 60 into minus 2 alpha plus 5 into 4 minus 2 alpha plus 4 into 3 alpha minus 20 equal to 0. That is, I get 10 alpha plus 60 minus 30 alpha plus 36 alpha minus 60 into minus 2 alpha plus 20 minus 10 alpha plus 12 alpha minus 20 equal to 0. that is I get 16 alpha into 0 equal to 0. Note that this part is becoming 0 for only one value of alpha. This part is 0 for every value of alpha. It means situation is of the type that the line is lying in the plane P2 and cutting the plane P1 at the position where alpha is 0, that is at exactly one point. That is, I can say the line is of the type BC or CD. That is, it can become the edge of tetrahedron. Hence, I have concluded that the line can become edge of the tetrahedron in the case of A, B and D.